Hi everyone, welcome back. In this tutorial, we're going to build and run a real Node.js application using Docker and Docker Compose. So far in this series, we've learned how containers, images, volumes, and Docker networking work. Now it's time to put everything together in a more realistic project. In this example, we'll run a Node.js application and a MySQL database together inside the same Docker Compose environment. We'll also learn how containers communicate automatically, how Docker Compose orchestrates multiple services, and how modern containerized applications are structured. Let's get started. Before cloning the project, let's quickly visit GitHub. GitHub is one of the most important platforms for developers and DevOps engineers because it allows us to store, share, and collaborate on code repositories. In this series, we are mainly focused on Docker and containers, but later we'll create a dedicated series completely focused on Git and GitHub, where we'll learn concepts like repositories, commits, branches, pull requests, and collaboration workflows. For now, we'll simply clone this sample application and use it for our Docker Compose example. Now that we clone the project, let's take a quick look at the application structure. Inside this repository, we can see several important files and folders used by the application. For example, the source code, Docker configuration files, the Docker Compose configuration, package files, and application resources. This project already contains everything needed to run a complete multi-container application using Docker Compose. Instead of manually configuring every service ourselves, we are using a real-world sample application to better understand how modern containerized environments work. Here we can see the Docker Compose configuration for the application. Inside the services section, we define multiple containers that belong to the same application stack. The first service is the application container. This container uses a Node.js image, exposes port 3000, and mounts the project files inside the container using Docker volumes. We can also see environment variables used to configure the database connection. Below that, we have the MySQL service. Docker Compose automatically downloads and runs the MySQL container and also creates a persistent volume to store the database files. And even though we don't manually configure networking, Docker Compose automatically connects both containers together so the application can communicate with MySQL internally. Now let's start the complete application stack using Docker Compose. With this single command, Docker Compose automatically downloads the required images, creates the containers, creates the internal network, and also creates the persistent database volume. Everything is orchestrated automatically from the Docker Compose.yml file. Now we can see multiple containers running together as part of the same Docker Compose application. We have the Node.js application container and also the MySQL database container running simultaneously, and Docker Compose automatically manages the networking and communication between them. We can also open Docker Desktop to visualize the application stack graphically. Here we can see the running containers, their status, ports, and logs directly from the Docker Desktop interface. This makes it much easier to monitor and manage multi-container applications visually. Now let's open the application in the browser. As we can see, the front-end application is running successfully through Docker Compose. Even though multiple containers are running behind the scenes, Docker Compose automatically handles the networking and communication between the application and the database. Now we can interact with the application normally by adding tasks directly from the browser. Notice that after refreshing the page, the tasks still exist. This happens because the application data is being stored inside the MySQL container using persistent Docker volumes. Now let's look at the application logs using Docker Compose. The Docker Compose logs command allows us to see logs from all the containers belonging to the application stack. Instead of checking containers one by one manually, Docker Compose centralizes everything into a single output. Here we can see logs coming from the Node.js application and also from the MySQL database container. Logs are extremely important in real DevOps environments because they help us monitor applications, troubleshoot issues, and understand what is happening inside the containers. making it easier to manage complex containerized applications visually. Now let's stop and remove the entire application stack. With Docker Compose down, Docker Compose automatically stops the containers, removes the network, and cleans up the environment. This makes managing multi-container applications much simpler compared to handling containers individually. And now we can see that the application stack no longer exists because Docker Compose removed all the running containers automatically. Let's go back to the browser and refresh the page. As we can see, the application is no longer available. This happens because the entire application stack, including the front-end application and the database container, was removed by Docker Compose. Now let's start the application stack again. Earlier, we stopped and removed the containers using Docker Compose down, but remember that the MySQL database was using a persistent Docker volume. As we can see, the tasks still exist even after removing the containers. This happens because Docker volumes store the database files outside the container file system. So even if containers are removed, the persistent data remains inside the Docker volume. Notice that the application connects to the database using the service name MySQL. Docker Compose automatically creates an internal network and provides communication between containers using service names. Now we can see the Docker network automatically created by Docker Compose for the application stack. Inside this Docker network, we can see both containers connected together automatically. This allows the application container to communicate internally with the MySQL database container. Before finishing, let's summarize the architecture of this application. Users interact with the application directly from the browser. The Node.js application runs inside a Docker container and processes the incoming requests. The application then communicates with the MySQL database container to store and retrieve the tasks. Docker Compose orchestrates the complete environment automatically, including the containers, networking, and persistent storage. This is much closer to how real modern backend applications are structured in containerized environments. And that's it for this tutorial. Today we built and ran a real multi-container application using Docker Compose, Node.js, and MySQL. We also explored Docker networking, persistent volumes, centralized logs, and how Docker Compose simplifies container orchestration using a single configuration file. This is much closer to how real backend and cloud-native applications work in modern environments. Thanks for watching, and see you in the next video.